a long time. Okay, then now the implementation principles are very simple here. Okay, so we are experiment driven. We cannot, with the people involved at the budget we have, we cannot do other than that. With the attempt of, we select these cases so that we want to prove, we're trying to, through them, try to address some of the important paradigms that we want to. And in particular, this long-term preservation of data and possibly calibrating pipelines. This is the concept that later on we realize we're missing something, and this is already happening with Gaia. We know that. At any data release, we discover that we have to do more calibration or different calibration. Thus, this will happen forever until we decide it's not worth to do it anymore. So this is already a given. 5 minutes. Okay. So because of budget limitation, then we're choosing the hardware very close. Okay, so we're now just about to decide, and you will see a snapshot of what we're going to do. Okay. So the expected results are very simple. We just will publish the results on the 3 experiments that I will show you in a second, and then a final report, which I was tempted to call white paper, but we are in no position to write a white paper on these things. So it will be a final report on this experience with a forward looking. Just to tell you that there are engineering data, just look at this one. So look at this fringe. This is the BAM monitoring device. This is the metrology system on board. And this is what happened during a CME event in 2017. So this is precious data. By counting how many, how do you call those? Jesus, okay, you know what I'm talking about. Those events there. Those are rejected by the pipeline, okay? This is the, by counting them, you can, and go back to the event, you can actually come up with the strength of that event at the position of Gaia, okay? So these are the 3, I will go through them very quickly. So we will look at the AGNs in Gaia. This in particular blazars, which have time scales in their variability of hours and maybe days. Okay, so you might remember these objects have intranight variabilities. Okay, which for an extragalactic object, you know, this is impressive. And then we're trying to see what Gaia can do in terms of supporting the Gravita initiative. Okay, this is a low-key experiment for now, because when we heard that you need to have information within half an hour or 1 hour, right now, a query like this for us, and you will see why, it will take 2 weeks. So at the moment, you know, doing this. So we'll try to address this issue of this requirement on quick turnaround with important daily data on these events. The reason these numbers are huge is that, you see, we have 1,200 billion observations already in-house. Plus the 2 years extension we go already in place. We'll have 16 billion observations. And these are cutouts already. I didn't know this was so important for this. But these are already cutouts, because Gaia could not download the whole pixels. So these are already cutouts. You know, the patchwork has been done on the satellite. Okay, so data extraction. So we'll do these queen queries. So given the system we have, remember the database is our main database from which we have to get the data is a very live database. We're still getting the data going in. So it's not, as we call it, dormant, so that we can actually use it as we wish. So this will go in competition with the daily activities and the cyclic activities that we do at the BCs. So this is but what I want to call your attention at that besides the complete source, which is basically the catalog that the SSDC handles so nicely for the astronomer, for our users, we will have to have the transit data. So we want to look at whatever is happening on the sky, photometrically and astrometrically. We can actually look at that before, during, if possible, and after the gravitational wave events. Okay. I will, you'll give me an extra minute, okay. But I can. So data transformation, okay, and there, very simple for us for the moment. We have G-beans, the most absurd, and Java, sorry. When I think of Java and G-beans, this has been a big failure for Gaia. But anyway, you might not agree. So transformation to FITs and possibly CSVs, so standards. FITs, it's a must for astronomers and for data preservation. There are arguments, and then the need for exporting methods. If you go back to the second, this is one of the paradigms that we think it's important to prove. Okay? And so by addressing those two, we will go into, we will make consideration on curations and preservation. But that's all we'll do in terms of curation and preservation. Just to show you something that cannot be done in terms of recalibration. This is the recalibration of the whole astrometry. You see, we need a small supercomputer in Altec, some external checks, and the supercomputers in Chineka. This is something cannot be done, okay? So this will remain, the solution of the whole sphere will remain something which is Gaia, and that's it. So, and these are the last two slides. This is what we're doing. This is a simple lift and shift approach with Oracle, because it's the quickest. And we can save a lot on the hardware. So what we're doing, we are accessing the repository at the DPCT. This is the Gaia repository with everything. We just do the queen queries for the tree, according to what we need for those projects. And then here we do two things. We transform the data, okay? And we apply our methods to do the science for those three. And then we just do shift, and then we do a shift and lift. So that when we're done with that experiment, we put it up there, and if needed, or the people will come back, we can go back and give them the results, and if needed, we can actually go all the way back, but only if it's strictly needed. And this is the actual, this is the DPCT, and you can see the characteristics, and that we're gonna do. So where is Ricardo? So I'm officially entitled to, yes, we're ready for the shipment, so anytime, okay? Good. So, and this is, so we have this machine, Trieste is willing to lend it to us, and then we'll base this as for the data transformation and the new database, and then we'll do the other processing with the workstations that we have available at the PCT as much as we can. So the conclusion is right here. It is feasible, okay? It was with the budget we have, okay? We don't have much. But thanks to these savings and careful design and careful choosing of the experiments, this can be done. The delays, which we have delays, it has been with the fact that it is not possible. Remember, DPCT is the first operational 1.5 petabyte under configurational control of astronomy data in Italy. This is really working. Okay, so this is something that we have in Italy, and INAF owns this 50%. Okay, this is something that we should remember. And so, with the extension and stuff, it has been done critical. So we have to shuffle data, and it is a lot of administration on our Altec colleagues. So this has been the major source for delay. But now we can do it. So the extractions for the experiments are already underway, and experiment 2 will be used as science cases, the event that are already known, okay? The 2 or 3 major ones, and see what we can see in the data. This has been identified, so we now actually, as I told you, we're gonna get the machine and then buy some storage, extra software, but so we have the resources we need at this point. And then we are recruiting data scientists. I mean, I don't have to say anything more. We all agree that these are people, and we are recruiting one for this particular effort. Sorry. Yeah, thank you.
Thank you, Mario. Of course, very interesting. Quick question, please. Okay, please, Gianluca. The microphone? Lost. Okay.
Come here, Gianluca.
So thank you, Mario. How do you select those 3 use cases for the analysis, and do you plan to test, other ideas for different analysis or different science cases to be addressed with this prototype?
The answer is very simple. The choice was something not in the Gaia core science. Now, you believe it or not, but nobody thought of blazers. Now, I have to tell you the truth, and the project liked it so much that now has become part of the Gaia. But fortunately, Torino is being responsible for this, as of 2 days ago, actually. They decided to adopt it. There was a proposal out. But this remains the base for a quick turnaround on this object. And we'll be looking for known ones for the moment, so that we can characterize the data. So, in principle, yes, any ideas we could try, and they are welcome. The Gravita was a request that we got a long time ago from Enzo, and then he said, "Oh, can you send us something within 2 hours?" And we start laughing at some point because it was basically impossible. But then we liked it so much, and especially astrometric data, I think, I don't have the time, but it's monitoring the star pairs, asterisms on the sky as a function of time, which is something that could actually be, not for the galactic ones, but some of these events, we could actually something indirectly, looking at the changes in the separation of these stars, which is something that might actually, by looking at the age variation that astrometric, I would say, you can also infer how big the mass of the source could be. Okay, this is just the basic ideas. And then the third one is actually a choice by Altec, okay, which is one of the reasons they entered the project at the beginning. But other ideas are welcome. Yeah.
Thank you very much. Please, Riccardo, next speaker is. Sorry. Is Riccardo Smaraglia that will introduce us to the Sky Regional Centers. Rosie, are you online? No, we cannot hear you, but is okay. Please make me the question or clarification on the chat online.
Chat, yes.
Yeah, sorry for that.
So, as you told before, we're talking about the Sky Regional Center, with the presentation was made originally from Rosie Bolton, from the Sky Regional Center project scientist. I tried to reduce information that I already have, and I want just to talk which is the news, which is the evolution that we have inside not only Sky Regional Center, but in particular in INAF about this direction. The key science, of course, the science is driven. You see that a list of some key science. I will not stay here to explain about that. Science people probably already know well more than myself. I just will remember that the SCA is starting more or less about in phase 1. I prefer use this slide that I remember that mainly all the group that work in the element about SCA already finished the ICDR, and practically we are in the middle of the phase where there is known as bridging, where there is just from the end of the CDR to the start of the real construction phase about SKA 1. But what do we expect? We expect this usually big amount of data, starting from that 2 petabytes a second, that would arrive to correlation, correlator, and so on. But the important number, the pointer was somewhere, okay, is about 300 petabyte years at the end of the phase 1 of the SKA. For the low frequencies, amount more or less the same about that high frequency telescope. Just remember that the upload to Facebook is about half of this one of these two channels about that. Of course, SKA will go ahead on 600 petabytes a year, more or less, when you want to use to science for the science. This means a big effort. This means a big investment from manpower for computing, really hardware, networks, and so on. This means a lot of work. So, as I told before, you're just in Rome, and here was the party, but in ministry there is the signing ceremony was made a few months ago, and they are waiting that all the countries already involved in the SKA will sign the treaty, because this must become, for example, in Italy, a state law that will to release a big amount of data, the amount of money, data money, every year to improve, to use this big instrument that will be the future about the radio astronomy and not only. So, the point that usually people don't know or already know is that the data of SKA, or the cost of SKAs arrive until the central data center, one in South Africa and one in Australia. Then the distribution of scientific data to the users will be arrived directly from the regional center that is not part of the cost instrument, because any partner or any country, we have to define how much we want to contribute to it and how much data should be have to it. But to have a very organized, well-organized system, a well-organized SCAR regional center, of course, the people and the country must be understand how to interoperability, make any kind of interoperability about this data. This means not only data, this means also about the computing power to do it, about many things, how to, for example, access to the data, Italian data in Australia, or that the Australian data can be stored there for any things in Italy. So we have, there is a new group that has been established to take and develop this SCAR regional center. This, of course, is very important, because at the moment there is not, for SKA, from the instrument, there is budget arrived directly from the SKA office. The other part, the single counter will discuss how to work together. To do this, and a group of a steering committee has been created for one representative for only member state. In Italy, the representative is Andrea Possenti, who is part of the SKA steering committee, and of course we are to define how this regional center will work. Of course, depends how much money the original country or the agency will be involved about that. The main target of this Severin is already one of this group. Of course, if he tells something not correctly, completely correct, please change me and correct myself, because I try to explain what I know and what I understand from talking with you and, of course, Andrea Possenti, but so probably I'm missing something. Oh, wow, go ahead. too fast. The first target is to create a white paper development page, a fast document, but with some important things. The operation, which is the operation, common software platform, roadmap, description, the body of the regional center. Remember that since that the agency, local agency will define the budget, there is a little of free level of decision, but of course must be working together. To define this, also the working group will be soon developed and soon open. One about, of course, all the data, all the important things about any kind of regional center. So for management system and so on, you have this list. But just one point that you see that there is only one point in Europe, because Europe, with the NEAS project, as example, like starting point, defined to have and subset. It should be one set of one of the regional center in the world, but also the regional center in Europe, we probably maybe not one, but can be spread around Europe too. So a subset of that. A Tier 0 is Australia and South Africa. Tier 1 will be the regional center. Tier 2 will be probably, maybe I hope, the Italian regional center too. So, working group is coming soon. Workload management, data life, quality of service, many definitions we have to define, probably without invent, but find something around the document. And so, users about archive exploration, this is one of the points about this meeting, and so on. Science gateway is another point, because I already know we don't have we are talking about 600 petabytes. One single one atomic observation is several terabytes of data. Usually it's a little bit difficult to use it with my local PC, and so on. So many of this group is working on. But let me go ahead a little bit. Science. 2 minutes, okay. What about, of course, if you are interested in Italy, contact directly Andrea Possenti. If you are interested outside Italy, there is Rosie Bolton that she's connected directly by Meet, I hope without any question or particular question. What about INAF? INAF is involved a lot about SKA, in particular about SKA regional center. I already nominated the NEAS project. The NEAS project is talking about the European regional center, where INAF is one of the main partners, but also our facilities, people not only, but our facility as a Pathfinder is very involved in this evolution. One is about the data center, about that ANA, authentication authorization activities, but also was one of the hosts that the first data science SKA data challenger. So we already host some data from SKA in simple mode, but there is the starting point. There is the people from Medicina, from Catania, about computer science, about any other activity, also inside the NEAS, and so we have a lot of collaboration. And of course, there is some collaboration activity in progress about LOFER, is a Pathfinder, about ASCAP and so ASCAP MERCAT, to try to understand which is the best way to manage and to use this big amount of the data. But to do this, of course, another point that we're already talking these days is which is our landscape, about the network. Usually when we talk about SKA, you talk about 100 gigabits by second all around the world, full bandwidth. But in Italy we are already present with the GAR, of course, we already know that we have the GAR, we are pay a lot of money every year about data, so every day. And they're ready to do this. We have HPC computing about Cineca. In particular, many of you already know that we have and Euro HPC pre-exascale will be present in Cineca in the next features. And about all infrastructure already present inside INAF and interaction with many Italian entity check italiani. More or less, this is the last side. So, we must remember that I already have a lot of information. So, enough, we are already at the HPC, distributed infrastructure with this first one, practically a chip project that many of you already know. It is one of the point about last starting point about the Sky Regional Center. We have the MU with Cineca or HPC computing. HPC means a lot of parallelism level, not embarrassing parallel. This can be by cloud, but we are also involved in the commercial cloud because we are interested that, I just finished, I'm interested to understand which is the technology that international commercial cloud can be offer us and define which is the price, good or not, but we know, before tell not, we have to understand what do they have. And so on. We have, in particular, already two big data centers here. The SRT will be ready for that SRT data, but be part of the network. And last but not least, we are very involved. When you talked this morning to with Latanzi about the biggest data center, we are very involved in the Technopolo, like a concentrate point, a starting point for the hub, stellar hub, about computing and data in Italy. That is all. I hope you have understand something.
Thank you very much, Riccardo. We can switch out of the presentation and move to meet. So, Rosie, if you want to add some information, or if you want to comment, please. Just a second, because we cannot hear you. The switch was not complete. I cannot hear you.
Not yet.
Rosie, please, could you try? No. Just a second. Unfortunately, we are not ready to let you talk.
No problem.
So it seems that everything was okay, Riccardo. You got the approval of Rosie.
Thank you.
Hello.
Oh, now we can hear you. Please go ahead.
I just wanted to say thanks to Riccardo. That was a very good summary. The only thing to add potentially is just to reassure you in Italy that each member country has a representation on the Regional Centre Steering Committee for SKA. So as far as SKA is concerned, it is really up to Europe to determine whether they present themselves as a single SRC or as several national SRCs. In fact, it shouldn't matter to the overall functioning, provided that each country stands by its pledges of resource. So it's an issue to be decided. And I think some suggestions on that will come out of the Aeneas project. And Riccardo, you also mentioned the Escape project. I just wanted to re-emphasize that within the Escape project, which runs to 2022, there will be opportunities to do prototyping work. So we will actually be prototyping federated data lakes and deployment of compute across distributed networks. So we actually will start moving towards having, on the ground prototype SRC-like structures in place. So it is moving forward well, and we welcome Italy's contributions.
Thank you very much, Rosie, for comment. Effectively, also Franco Tinarelli, in the next talk, we talk about a pilot project for SKA, a regional center, of course. No, this is not the next, not the next immediate one, but okay. Question for Riccardo, please.
Grazie. Can you? No, maybe he cannot. Well, actually, the question is, what is Tecnopolo, this project?
Tecnopolo is in Bologna.
But I mean, it's very interesting. I mean, is that a consortium forming?
It's consortium forming, yes.
Consortium that is called the big data.
No, stop. You have to repeat.
Okay. Is a consortium what was sponsored by Regione Emilia-Romagna, and in this building that are okay, we host the Center for European Meteorological Data that came from New England because Brexit, we have Brexit, and in Bologna we get this big data center, and starting from this, Regione Emilia-Romagna have put a lot of money, this is the concept, and Cineca and CNAF want to move in this Tecnopolo the new computer center, the new machine of a computer center. Now Cineca ha vinto, in inglese non lo so, il Cineca ha vinto il progetto Euro HPC, no? E all'interno di questo Tecnopolo vengono poste anche queste infrastrutture. Quindi, poiché c'è questo movimento, poiché c'è disponibilità da parte della Regione di Emilia-Romagna di metterci delle risorse, si sta valutando come riuscire ad entrare in questo complesso. E diciamo, come INAF, certo, come INAF, cercando di capire quali sono gli spazi che possiamo utilizzare, le risorse che possiamo metterci noi per allestire ormai i problemi. Comunque in questo caso, quando si parla di grandi infrastrutture, i problemi sono problemi di infrastruttura, cioè di... Sì?
Siamo durante la discussione.
Sì? Ah, ok, va bene, stop.
More a question for Rosie Bolton, not for Riccardo probably. Is Rosie listening or not? I don't know.
Listening, yes.
Ah, okay. E Mugo Becciani, Rosie. The question is if there are some discussion or some activities to coordinate the 6 regional centers in the world, not only the European regional centers, and if there is a minimum set that could be arranged between all the regional centers that the SKO could address.
Sorry, a minimum set of what?
If there is a sort of a coordination between the different regional centers in the world, and if there is a sort of minimum brick into in the wall of the regional center that could be guaranteed for each regional center.
Okay, well, so yes, Ricardo mentioned the SKA Regional Centre Steering Committee. The function of that is to perform this coordination between nations, and that will eventually evolve in some form into a body which unifies the actual SRCs themselves when they exist. So they absolutely have to be coordinated, because we need to understand how much compute resource we need, how much storage we need, and that's, you know, on a global scale. So not just, you know, so different countries will put in different amounts, but it would be collectively a responsibility. And we'll also want to work out how best to share software amongst the different SRCs. So the vision is that they should behave in a similar fashion to the worldwide LHC compute grid, in that everyone puts in what they consider to be a fair amount of resource and effort, and then each nation's astronomers would take back what they need, and not necessarily have to worry about which regional centre the data they're accessing actually is located in. That's the vision.
Okay, many thanks, Rosie. We have to go on, so please, Fabio Vitello will introduce us to the Via Lactea project and new development for the, Via Lactea visual analytics tools for star formation studies. Please go ahead.
Thank you, Christina, for the introduction. What I would like to show you today is the tool that we developed for this FP7 project named Via Lactea. But before to start to talk about the visual analytic, I would like to tell you something about vivo. Vivo is our visualization tool that we started to develop in 2005 as collaboration between us, so Observatory of Catania and Cineca. Vivo is an acronym for Visualization Interface to the Virtual Observatory. So we keep in mind that we should talk with the VO protocol and we should interact with VO staff. What is Vivo? Vivo is basically a suite of tools. We have a desktop application to visualize data. We have a server-side application to run in grid-like environment, cloud-like environment, and so on. Then we develop some kind of visualization on mobile platform, and now we are moving on visualization for Meerkat Data Cube using virtual reality technology. So in order to validate the sources extracted with Source Finder, you can explore and validate the source and know about the source. So, as I said before, we developed this kind of tool in the aim of this project. Basically, we had a work package for technology, for tools, in which one we collaborate with our colleague of Trieste that develop database and virtual observatory infrastructure. I will show you later some few slides. Then we had a collaboration with colleague in Naples that develop data mining algorithm to extract information about source. And then we have, of course, our visual analytics system and science gateway to allow the scientists to make some kind of computation and to make some kind of analysis using a web-based portal. So basically, we have this kind of ecosystem where data extracted to the data mining algorithm are ingested in a knowledge base that we can access to the virtual observatory staff from our visual application or via the science gateway. Basically, the knowledge base, the Via Lactea knowledge base, was developed by a colleague of Observatory of Trieste, Marco Molinaro, Robert Butora, in particular way. We have some storage of files that include 3D data cube, 2D image. Then we have database resource that stores physical properties about the compact source, for example, and then we can access through VO protocol, table access protocol, we can access data and table data, and then we have search and cutout to access images. Now they are moving to implement SIA protocol to access image to a VO compliant way. And then we have our visualization application, our visual analytic client. The idea behind this kind of client is to allow the scientist to combine different kind of data, to make science combining data from different wavelength, but also combining 2D image with, for example, 3D data cube. So I would like to show you some video about the application. Basically, we want to hide all the complexity behind the technology, so user can easily identify the region to study, and select the wavelength to start the analysis. We have a lot of different kind of wavelength ingested in our database. We have radio survey, optical survey, and so on. Then, after the visual selection, so the user just select the region, obtain in automatic way the image. In the upper right part of the application, all the inventory of data present in that area are shown. So basically clicking on one of these data, the footprint are shown just to know where that data are located in the visualized image. Again, without any technological knowledge, user can click and download data and make some kind of combination of different kind of visualization. So one of the key points that we achieve with this kind of tool is the interactive between different windows. I will show you later. Basically, we have now this kind of, Okay, we have different kind of visualization. We have a 3D rendering of the CO cube that you can move and explore, and then we have a cutting plane that you can move to explore the velocity domain. The velocity is shown here, and then you have a preview of the slice that you are selected in this velocity. As I said before, you can combine different kind of visualization. So the idea is to report some information that you can extract from 3D velocity cube in the 2D continuum image. So activating the isocontour function, you have the preview of the velocity on the 2D image. So you can just have some information about the extended source in order to know if they are coherent in velocity domain. And then, as I said before, we have access to tabular data with the table access protocol. The idea is to access information, for example, about the data extracted via the data mining algorithm in order to know the link between different counterpart at different wavelengths. So again, just selecting in a visual way the source, we have information about each counterpart in different wavelengths. So, for example, I'm activating a 500 micron wavelength, and so you can have the preview of the counterpart just upper the 2D image. And then, for example, I can have some spectral energy distribution plot. This is all the contribution of the source that belong to this big one. Again, windows are interactive, so if you click in some of this point, you will have in real time the preview of the source. So you can know which source is in this kind of visualization. Then we have some kind of fitting. We can do some fitting in this plot. So for example, I collapsed the contribution about all the source, and then I select an analytic fit that can be executed, and then we have the fitting about the source I selected. We also have some fit with theoretical model that are stored in the database. Even if the Via Lactea project ended in 2016, if I will remember, we continue to develop this kind of application. The Via Lactea application was selected as a pilot for the EOSC project, so we moved to have this kind of application in EOSC pilot project. Basically, we move the computation of spectral energy distribution into the EOSC platform. And then project is still continuing with this brand new project that we have just have approved a few months ago. It's a quite big project with a budget of 5.6 million euros. It's led by the National and Capital University of Athens. HINAF is the second biggest partner in the consortium. We also have Altec involved in this kind of project. Basically, the idea is to develop some EOSC services for three communities: atmosphere community, underwater community, and of course space community, that is our community. We promise to develop three kinds of services: one for data management in a fair way and visualization services, one for the map making, and one for structure detection using machine learning techniques. And in the context of this service, we signed an MOU with the University of Malta in order to have some PhD, some common PhD that will be involved in this project. Thank you.
Thank you very much, Fabio. There are some questions. Oops. Yeah. So ready?
Thank you, very nice. Is it configurable for the TAP services? The one you can, the catalogs you can choose from different registry, you can use it like a top
yes,
cut? Like
you can set the endpoint of the TAP services,
yeah.
But of course it's customized for
yeah, you have the
our,
default,
yes,
default values.
When you query the database, you can put your own link.
You can change.
But we are, I mean, we should move on this direction, because when we make the tap call, we expect some kind of fixed column. So we know that in our services we have the column.
You need that column.
Okay. Yeah, but we can extend in order to allow the user to choose, okay, which one is this, which one is this.
Okay, good.
But in principle, yes.
And set fitting,
yeah.
Is it without a model? You have
we have analytic fit and fit with theoretical model stored in the database.
Two.
Yeah, in the video I choose just to have one of the fitting, but we have more or less 20,000 model.
Oh.
No? 20 million of model, sorry.
Okay, thank you very much.
Other questions? No, I have one. Yes, there was equivalent to that one. So it is very fast to implement also to other catalogs, I suppose. Yeah. And it is possible also to introduce some calibration stuff.
Calibration stuff.
That means that you got raw data and you want to calibrate it with the photometry, with something like that.
Up to now, no. But if we have this kind of request from the final user, we are happy to implement it.
Wow, fantastic! Thank you very much. Yeah.
Can you overplot personal data on image to compare with the ISO contour you shown?
You can load your FITS data and apply. FITS. Yes, we start from FITS cube or image, and then you can apply all the things that I showed.
Yeah, but I was not talking about data. Contour or other.
No. We load the contour stored in the knowledge base. But again, if this kind of request come from the final user, we are happy to do.
Thank you.
Thank you very much. No other question, I think. Thank you again. Next speaker is Franco Tenarelli, that will introduce us to, I don't remember the title, but we got here. Data exchange and computation between data centers using common ANA. Thank you, Franco.
Yes,
only one moment, vista, qual è?
Modalità schermo intero.
Modalità schermo intero, ok. I am going to talk about data exchange and computation between data centers using common day. This presentation and the work it described was done by Sara Bertocco, Giuliano Taffoni, and Cristina Knapic of the with me, yes, for the Astronomical Observatory in Trieste, and describe use cases for SKA Regional Center, for AENEA's Work Package 6. WP6 will focus on processes, protocol, tools, and services required to ensure interoperability between existing SCA-relevant infrastructure by addressing topics such as seamless authentication and authorization infrastructure across the underlying network of services provider. Essential to lower the barrier for potential user of the final SKA SDC. SDC is the European Science Data Center for INS. By enabling SKA user to access federated services and resources offered by different infrastructure providers in Europe and around the world. WP6 is also crucial to connecting INS with a similar effort worldwide. This is the schema, the functional schema of this prototype. Is based on a science gateway catalog to retrieve the data, a web task, web application to do authentication of the user that on the data, a group management system to authorize the user to reach and compute the data, and finally the data center to data access and computation. Now I describe this actor. The Science Gateway is the entry point of the data retrieval. It is able to query the archive of observational data using standard view queries. This is very important. It is usually dedicated to observational project of one organization, I hope. If the syntax of the proposal ID become a standard, it called a serve observational project from organization. In the example, the ALMA syntax of the proposal ID plus an instrument indication to use a different instrument with the same syntax. The goal is to reach the data with only one information, that is the proposal code or proposal ID. The Science Gateway catalog, the catalog contains information encoding use IVOA notation. Group identifiers follow the GMS current draft of IVOA specification that embeds authority, managing the group management services, the service identification to call for the authorization purposes. The authentication is not currently defined, but is being studied, and is the authority org that selects the method of authentications. And finally, the graph ID on the proposal dataset belong to. This, I think, is a well site to the metadata, the discussion of this morning, to the metadata that describe not only the data of the observation, but only the document, and probably of the task to compute this data. In the example, using on this prototype, the OutSCA organization, the grouper of a GMS, and the proposal ID with group ID. The RAP, the Remote Authentication Portal, is the software to authenticate the users. Is an authentication system built by enough capable to handle multiple accounts for web application usage. Was born as a SCAP reconstruction phase component, a joint venture between Radio Astronomical Institute and Italian Astronomical Archive. The first RAP prototype has been presented at the SKE-ATM Prototyping Strategy meeting in Trieste in March 2015. And RAP is used in the production portal of IE2 in conjunction with Grouper Science 2017. The current RAP version is able to join a different user account in a single entity, is account linking. RAP uses OAuth2 and OpenID Connect to communicate with the Science portal or other clients. Some things about RAP. The account linking, the join operation requires the user to always authenticate himself for security reason to his different identity. To the left, the federated authentication in the INAF is the IDP of INAF that is registering the game. And to the right, a Google personal account. It's strongly suggested to choose an institutional account as the reference one to join against to raise the security of the account and to guarantee that the unique ID will be not reused in the future. This is a very focal point, because if you use to mark the data one identity that is reused, this data is possible used by other than the owner. RAP is a proxy between application and identity providers or local registration, can be customized from application through configuration file. I have not a pointer. No, these are not good pointers. It's possible to choose providers or local registration and XS5 authentication. Can be configured as pass-through authenticator without the user registration. It simply authenticates the user and pass the information to services. Okay, 4 minutes, thanks. Use LDAP and SQL server to register the user at first login. The registration of the user is important to do join to do account linking. RAP is open source and so on. Okay. This is a simple layout of the remote authentication portal. To the right, the pass-through is proposed only the the authenticator services, and to the left, only few services, social services to authenticate. Okay. Another actor is the Science Gateway Group Management System. The Group Management System contains information about the group that owns the request or proposal ID. The group is identified by a group name, alphanumeric, and or a group ID numeric. Group use only a numeric ID. If the unique ID of an authenticated user belongs to the group associated to the proposal ID, then authorization is issued. The authorization contains a group ID and can contain a list of privileges associated with the unique ID belonging to the group. And finally, the data center. The data center exchanges the authorization token with the Science Gateway. The token exchange is already a draft for ETF, is different from the access token and for user authentication. The token is signed with a new client ID and unsecret because the communication of these tokens is only from
computers and not from user and computers. The data center retrieved the information about data group and user request, and the data center instantiates resources for the data transfer or analysis. And now a simple walk step by step with this prototype. Only one information, the proposal ID, only one authentication for the users. Okay, I have select and if you are authentication and authorized, you are the ownership of this data. It's possible to select the action to manage your data. Download experiment files. I think that with SCA files this is not a good option. Or obtain an account to analyze your data. The link is sent a link with the email registered when with your identity. A link because the communication of the username and password is secure with HTTPS page. With this login account, it's possible to log in to computing element and analyze data. This is a simple example of this as DS9, but in future coffee for is possible to use coffee and not cafe and non DS9, or in this example it's possible to send a public key to the data center to log in without a password in the data center. Is the same, you go on with no password but with the certificates and in the same way to analyze your data. Two final slide to describe the interaction already in use in the IA2 archive between RAP and grouper. Sonia Zorba of IA2 staff has modified two grouper connector to authenticate API as group administrator to manage group membership of archived data file, and using the two modified connector, grouper received the joined identity account linking from RAP. You see this at top of this example, because grouper use only LDAP to authenticate. It is not able to recognize the account linking. Thanks for your attention.
Thank you. Questions?
Oh, this is a good situation.
Well, I have
for
one.
My English.
I have one, of course.
Yes,
So basically, the maintenance of RAP is, this is more a comment than a question, but please confirm. RAP is maintained by INAF.
Yes.
It's not related to any kind of European project or project. It's something that is developed in-house.
It's maintained for this moment in my office.
Okay. And also in here too.
Yeah.
Because Sonia knows about that. And another point is that RAP will be... what? RAP
no,
is compliant with...
No, sorry. Only one question. For Luciano, PHP.
Luciano asked if you have DOI.
No, but if you want
Luciano,
to recognize people, we can use our chip.
They really ask is, Riccardo, where is the DOIs of this application, please? Dove, and what is the DOIs of this application? Is a joke.
Now, I would like to also mention that is BPA compliant for the people.
Yes, for the people that don't know BPA. BPA is blueprint architecture, is a recommendation for the ARC2 European project that that try to standardize the operation of A&A.
Other questions or comments? Luciano, do you want to comment something else?
Semren, I am waiting. No, Italian, please.
Yeah, not Italian. No, I just was wondering, is the working draft for group management in VO, it's compatible with that? It will be compatible with that, or is compatible with that right now?
Yeah, no, but this is a problem of Science Portal, it's not a problem of RAP. RAP is only an authenticator. Okay.
Thank you. So we can start the discussion. So we plan to have a discussion about science gateways. But of course, any contribution that we had in this session is a source of our interest and our curiosity. So I would like to highlight a few points. The first is that with the big facilities, we will have challenging problems, of course. And Riccardo told about politics, not deep details on implementation of the regional centers for the SKA, for example, because we don't, exactly, we are currently only imagining the possible solution that we can offer, but of course, we are also collecting in the Aeneas project the requirements from the community. That is very important because it's the driver of every kind of implementation. What Franco did, I start from that because of course I'm involved in that, so I can say about it, is to try to interpret the several ideas that came out in the SKA pre-construction phase. So we had some contribution for international partners that collaborate with us for several things. We were involved in the observation management. So we start from the proposal submission and then RAP starts from there. But I think that the problem of authenticating and authorize people to access resources is for every kind of data provider the same. We try to make some usage of standards as much as possible. I don't know if this habit is diffused in the astronomy community, and I would like to ask to the community if it is interesting, this approach, if of course you see as necessary to adhere to as much as possible to standard, not only for data publication, but that also to data access. That means private data that we have to access via authorization. So Severin already said that your data center is built on the standardization, from the standardization point of view, and the AVOA in particular. I suppose that ISO has the same policy with quite the same standard, but if you could again comment about this approach that you got, in the sense that each data has the ownership, you can assess, share, etc. Your, thank you.
So what we've done is promoted, first of all, within the IVOA is authenticated access to all the services, IVOA services. And with that, we have built all the access to both CDC and CANFAR services with authentication, so that we can support proprietary data queries. We can protect metadata in the TAP service with authenticated queries. We can support authenticated access to data files. We can support as well is authenticated access to processing resources, authenticated access to storage resources, and even group management where you can have an owner and an administrator, groups as well. So something like this in a science platform where you have your authentication and, well, it's really your authorization built into every service, and that way it's the same thing across, it's a uniform experience for your users. And you can answer the question of whether this is a public service or a public data, and then protect the teams. I mean, we protect databases for teams because they're putting together their paper and they're accumulating the results, and that belongs to the team. That database belongs to the team. So it's really built in to it, but it's also not, how shall I say this? It's, the point I made on Tuesday morning was to not tie this to an institutional service, because, for example, in Canada, within the National Research Council where I work, we have our own authorization and authentication system. The platform has its own, so we can support users which are not institutionally based. They're located around the world, right? So it's important to make that distinction. I wouldn't recommend that you use an ENAF LDAP system for an ENAF-wide authentication and authorization system to data, because you want to share this data across the world. It's not, your teams are not. So it's nice to make that distinction and build it into all your services to use the same system. And it cannot interoperate, right? Because we had an interoperating example between ENAF and CDC, where a user in ENAF system was granted permission, but that's not a group that we managed. It was a group entirely managed here in Italy, but was able to access data in Canada because we gave access to the group. We did not give access to the user, but the user group was managed here.
Thank you very much. I would like to add what you said now, that there is a different layer between what are the credentials for the users and are the credentials that from the services go to the infrastructure. And that's the reason why, okay, I can spoil it. In NS, we will propose 2 layers. The first layer is at the level of Science Gateway. We will have the interaction using the VO standards, and behind this, we will have the interaction using the blueprint architecture, that is to use different infrastructure, different data providers, etc. Sorry, data centers, not data providers. And another important point is that, okay, now we got the access of the user, and then we interact with where is Fabio? He's gone? No, the other Fabio Vitello. Okay. Okay, I hope he's okay. Wow. Okay. So no, I was saying that now we discuss about user access to services, etc. And now I would like also to discuss about science gateways and what are the main operations that the user can perform over remote resources. And this means that the first approach, probably also yours, if I correctly understand your presentation, is to have access via browsers. So you delegate remotely computation, etc. You do not import anything. Also because with the, it is quite impossible with a large amount of data and high performance computation. So this approach probably will, for sure, sorry, will adopt by the SKA regional center in order to allow the users to interact and to reduce or perform other actions over the data and of course share. Could you comment on the usage of your application? Is it I suppose that you respond to all the requirements that the community had, but please.
Yes, we start to develop Science Gateway for different projects. So we have basically one Science Gateway for Visivo staff, then we customize the Visivo Science Gateway for Via Lactea community, then we have Science Gateway for Cherenkov Telescope Array that was mainly to access let's say a prototype for authentication and authorization that we develop inside the ARC2 project. So basically we customize the gateway considering the input from the final user.
Sorry, no, if I can add some 3 cents to the comment of Fabio. We also are working with the colleagues of South Africa for the virtual reality tools, and we are thinking also on access to the data that are in the cloud using Science Gateway in the same way that we do for Via Lactea, for example, using the TAP protocol for extract data that are inside a specific region. So with the idea, and with Russ Taylor and Tom Jarrett, we will start this activity just in this direction in the next few months.
And another interesting thing is to interoperate also with the containers via browsers. That probably will be the best way in order to guarantee a customization for each kind of users about specialized data processing. So this means that there is already Sevran yesterday, yes, introduced us to your experiment with containers, and that is web browser based, and of course requires some extra work for us because we have to implement, but probably also some, for example, I don't know if OpenStack supports the web browsing of virtual machines, as well as, I don't know, for Singularity or what you adopted, Dockers, for probably Dockers, okay. So if you want again to comment. Sorry.
So this is a prototype. We haven't actually released the service to the community yet, but the idea is that we would provide web access to analysis, and it is being driven by the ALMA community in Canada, where you have all these different versions of CASA depending on your data. So we basically will be creating and providing containers of different versions of different software packages. So at the same time, our CANFAR resources, which are basically cloud resources, will support with Kubernetes the scaling out as more users come in, depending on the memory needs and the CPU needs of the software package. We could actually then support different users simultaneously using this service. So with virtual machines, yes, a user could set up a virtual machine and do some processing with it interactively, but we found that bar was very high. Expert users and virtual machines could get by, but not. So this is a different way of providing software to users, ready to use, but not close to the data in the data center.
Thank you very much. Mario, do you want to comment your activities related, in particular, with the technological stack that you adopted? Just a second that I come. Oh, okay.
Because I've seen the SCA petabytes, which are already impressive. Now, the question is this flat files? Is this? Oh, well, come on, you can. Sorry. The people on. So, is this flat files, or is this DBMS protected? I mean, is this under configuration control of these things? I mean, what is there? Because that is my concern. And the problem is that because we heard not much about databases today and all of these days. And I can comment on Oracle because he's advocating Oracle. Oracle is Oracle. Very controversial thing. We don't like to be under, no, controversial, I mean, it's a wonderful product. I mean, it's never had a crash over 5 years. So which is, these things don't come for free, but it has been very cheap for enough. This is very cheap for us. No, but let me finish. So the point is, I think this is crucial because the preservation and everything, I mean, this must be managed. And, for example, Oracle is very expensive in terms of, I mean, the 1.5 petabytes, half of it is management tables. It's a relational database, as you know. So what are those numbers? When I see 3.5 petabyte, or what is it? Is it just data or?
Data are visibility data.
Stop.
Raw data, very raw data. Okay, very raw data that we have to manage as a single data set that you can split in different time because the standard is 8 hours of observation. You can split 2 hours, 2 hours, 2 hours, but are data set of visibility.
So the next step is I'm thinking of, because I don't think it's convenient to put all of them because it will cost dearly, I mean, regardless of the choice of your database. So, but then you can use some metadata to actually organize them so you can retrieve and is that being planned on or? Okay, I'm sure planned, but. Yeah.
For the Aeneas project, yes, Marcella say in this presentation of yesterday say this because you retrieve data with the metadata and you go to a regional center that have stored the data. In 5 in Europe, 2 one in Australia and 1 in England, 2 bases to store the data and 5 distributed in Europe, correct?
So Vincenzo, you are taking in the loop because, of course, you are in the work package, the right work package to.
Yeah, the WP5 of Aeneas about how to interact to bring the users to this data, and then starts the processing from the STP, the products that are not science ready. So the need is to have at least to start with a group from the proposal level. So we have, from the point of view of the authentication authorization, so I'm also involved in WP6, we have this problem connected to the fact that we have the SKA office and then the infrastructure to do the processing. So we have the first level of proposal in which there is a group submitting a proposal and is stored within the SKA headquarters system, the observational data archive that maps the proposal ID with a given group of investigators led by API. But basically at a later stage, there are other actors coming into play at the level of a regional center. There are further collaborators that could be added by the PI at a later stage. And then also people that contact scientists like the Alma Regional Center, just to give a model of interaction that we already have in place in INAF, in order to translate the request from a scientific point of view, in order to reach the science goal of the original proposal, into a really science-ready product. So to translate this into computational and storage requirement in order to optimize the resources. And this implies to have some test scratch spaces in order to perform some tentatives, because to perform, for example, reimaging in order to improve the image products and some other stuff need to suggest. So you need to monitor also if something goes wrong, to implement all the necessary testing pipelines first to submit a job, because we are talking about a huge amount of data and huge computational requirements spread all over the networks. And even a single all the total amount of data could be split in several different geographical places. So take in this point into account, because it's not feasible to, for example, bring as an Italian community all the Italian PI data in Italy. This is not feasible, I think. We can buy lots of amount of space, but we should take into account that the dataset and the optimal way to implement this kind of distribution pushing mechanism for the SKA central data archive from the sites, from the telescope, toward the network. We can have, for example, one part of our dataset delivered in another place in the world. So it's more a concept of lake, a data lake, which it's dislocated with all the computing facilities dislocated as well, and sometimes we can also have different nodes with different expertise that will act on the same dataset for different science goals associated to a given observation. So we started to investigate this.
So the perspective is quite different from what you probably, because you got a database assessing by a community. Here in this case, we got data that will be assessed for several distinct PIs, and yeah, exactly. I would like to ask Fabio that introduces us to the recommendation from the EOSC, if there are also recommendations for building science gateways for that.
I'm not exactly aware of this, except that in EOS pilot, and here probably again the other Fabio is more proficient than me on this. There were some specific rules to build applications which are tied to the EOSC, and there is a shepherding activity. But there was a shepherding activity by the EOS pilot staff, which is actually EOS Hub staff. So it should be an activity that is durable in time. About specific assignments, these should apply also to science gateways, for what I know. But maybe the Catania group is more aware of this.
We doesn't receive any specification about Science Gateway from EOSC Pilot, but we keep in place one Science Gateway to access the EOSC computing resource. So basically our interface is, our visualization application is connected to a Science Gateway that is linked to the EOSC resource, but we have no particular specification. Yeah.
Thinking about the activities on the activities that we have been doing in our case at the SSDC, basically we have an authentication system which is managed internally, and of course there are users that are allowed. I mean, depending on the user, they have different privileges to access different data set, of course, and they are also allowed to upload their own data so that they can add their own information to the tools that we have. And the tools are usually run on server-based application, so that we transfer less data as possible through the network. So if you think, I think Angelo can comment more and will present a few things about Matisse. Of course, it is important that you have tools that are available to access data that are stored elsewhere in a, let's say, seamless way for the user. So the user really doesn't know where the data are actually stored. It just see that the data at some point appear within the tool, and he can play with the analysis and can do whatever he's allowed to, depending on his access rights. One thing related to the discussion of the SKA, I think, is to find also a proper balance between the needs of having some sort of production environment where you are really committed in reducing all the data gathered from the infrastructure, and an R&D environment where people can test their own applications. So, of course, you don't want to, you cannot afford to have 1,000 people concurrently trying to access a significant amount of data and running their own stuff, right? So this is something that is also controversial, because, of course, you want to be as open as possible in terms of exposing the data down to the lowest level. But, of course, this is strictly related to the science application and to how tightly those are connected with the lowest level of the data and on the data reduction pipeline.
Thank you very much. So I would like to come back to the previous question for the Bologna hub. So if you want to comment again, what will be the future of our data center in Bologna?
Okay, because in Bologna we have the happy situation, and our region, the regional, have put money in the building, in the set up the building, and to set up the infrastructure that is power, and that is cooling, that is all is need to put a big amount of computing. Now the problem is a problem of cooling and power, the first problem, because we spend a lot of money in this. Okay, we are exploring with enough a possibility to enter in the business, to enter in the big data consortium. We are in the data consortium. We enter in the data consortium with a request to have space, to have power, to have cooling, and there can be a site where we can install machine for SCA and for our application. Not only for SCA is the point now, is a clear point, but opportunity is that because Cineca put in the same building is a new generation of computing power, we can be a user of the Cineca computer power for high-performance computing, not for the data reduction of SCA, because I think that is another type of machine, is another type of computer that we need to make in the data solution. So this is an open table that we are exploring, if possible, to have this. In this, the possibility to have infrastructure to host data of other host for conservation, long-term conservation, etc., is an easy way.
Thank you, Mauro. So I think that now, I don't know if there are questions or other comments. Otherwise, we can have the coffee breaks, and then we will restart with the final session of this meeting. Thank you. We will recollect.
Faccio vedere le fotografie del... Aspetta, se riesco a fare il...
Ti ho mandato per email un file, la prima pagina è la sintesi. Secondo me sì, delle cose per giorno che secondo me sono più rilevanti. Poi fai quello che vuoi. Dopo c'è anche tutto il resto dello stock, dai. Sì.
Se volete vedere se questo capannone è in grado di tenere i vostri computer, io saprei un gatto. Ma è nel cloud, il capannone. Com'è? È nel cloud. Sì, il capannone è il cloud, non è nel cloud, è il cloud. No, ma mettici uno mio, perché se no si è vero. Io ho guardate, allora, guardate gli uomini che stanno lavorando per capire come quel capannone.
Sono 3.000 metri quadri per capannone, i capannoni sono 6, 4 del centro meteorologico europeo. Per non sapere scrivere, uno cineca e uno si tiene a quello. E ci metteranno i 3.000 metri quadri, ci metteranno il loro nuovo calcolatore che saranno a criterio, ma che userà qualche cosa sui 300 metri quadri. Un posticino di fianco mi sembra davvero. La Brexit è la Brexit. È uno dei 6 che ci affronta. Però se no e poi fra le altre cose c'è questo per cui questo punto non è che si
Se no, se vediamo le ferie tutte e due, facciamo discussioni della cosa. Se no, ora ci sono una festa di weekend e poi dobbiamo lavorare.
Perché sta andando benissimo. Stavo dicendo ti ricordi cambiare i tempi? Forse siamo un pochino.
Siamo questi visti. No, la gara era 2, là così, dopo si parlava per mezz'ora, poi
sì, è vero. Io posto la banda, ma come faccio a passare? La mia faccio passare mentre le
Era pessimo, infatti si vede e si sente.
Sei tu l'ultimo c'è? Sono io l'ultimo c'è. Sei l'ultimo c'è? L'ultimo c'è. L'ultimo di quel cano. L'ultima sessione.
19 luglio.
Di Bliss ha detto 12, 14, 16 archi addirittura
sì. Ok, bravi, hanno già detto noi stiamo ancora aspettando.
No, ma chi non deve decidere della congiunzione astrale?
Sì, ma le condizioni astrali si sanno prima, no?
No, perché la supernova viene si creano i satelliti che insomma hanno un'orbita determinata e il mondo no. Va bene. Oppure se vuoi scrivo io a tutti quanti
La testa.
però se Francesco mi vuole segnare meglio per anche un rapporto se vuoi presentare da solo il problema è che quindi non io lo vedo oltre quindi per quello si scrive
Però scusa, che è sto gruppo ristretto? C'era molto più gente.
Avrei un problema di quote blu.
Se la guardate la TV è meglio.
Avrei un problema di quote blu.
Perché così posso dire essere stato in televisione.
Per chi la vuole è più supportante.
Ho capito perché questa selezione di gente che contravviene molto,
Perché come diceva qualcuno fuori l'hanno detto.
sì, va bene, siamo sempre stati d'accordo, però esclusione. No, adesso
Everybody, please. We invite to start the first.
Vabbè, intanto ve la lascio.
No, apri la cartella però. La cartella delle presentazioni.
La cartella?
La cartella di presentazione. Okay, we'll start the last stage of our journey. We'll talk about data management in the sense of computing. We have a little change in the program. The first speaker invited is Dr. Angelo Zizzi, for a logistic reason. And he talked about high-performance computing and artificial intelligence for solar system activity in SSDC. Thank you.
Okay. Good afternoon, everyone. First of all, I would like to talk to you about Matisse, a brief introduction to Matisse, that is the tool for accessing planetological data by SSDC, because 6 years ago, its very first version has been present in Bormio. Now, after 6 years of existence and continuous development, in which we added the new features, we started from the Comet 67P of Rosetta, we added observation of Vesta and Sirius planets, we have now also connection with Vespa and other remote service. It's now time to release a brand new version of this tool, and since this morning we published a beta version online at that address, It's a very limited version of this new tool, but we'd like that users could start to touch it, use it, and give us feedbacks. Okay. This new version has been thought to overcome fundamental issues. We use a new DBMS that has been is best suited for geographical information system use. We have a user-friendly interface with the integration of planetary fits and JS9 in the output page, apart from the 3D visualization that already existed in the previous version. It will be also servlet-based, so it can be usable not only by a browser, but also by scripting. And of fundamental interest in this workshop, it will use advanced ICT solutions that we are going to introduce now. The ICT solution that we are talking about are those from high-performance computing and artificial intelligence that are, of course, interconnected. For HPC, SSTC is going to acquire a CPU cluster system based on their technology. The primary task of this line of research is to develop a set of software engineering techniques to apply parallel computing to actually existing non-parallel algorithms. But we have also a medium-term goal that is that of exploit commonalities between different science cases and so produce a single library. This generalization task will be pursued following a double path. A platform abstraction level and programming language level, and we will use as a reference platform for development Microsoft Azure Cloud, usable as a suitable workbench for this case. The case study for HPC that I'm presenting you today is that related to GRAM atmospheric retrieval code developed in IAPS by Davide Grassi. Is, of course, a serial code, so it processes a single spectrum at once. We are going to optimize this code for parallel processing, and of interest is to be noted that the resulting dataset will be added to Matisse. So Matisse users could exploit this new dataset. Yeah, this is the current scientific serial approach. It's straightforward that a spectrum at once, whereas a parallel approach using several independent spectra will retrieve a group of independent retrievals in less time. The achievement of these goals will open ways for other applications. For example, similar algorithms of atmospheric retrieval could be used for Venus, for example, and for exoplanets for the case of Ariel. Another interesting task we are conducting in SSTC is that related to artificial intelligence, in particular to information as data interpretation of computer vision. We are integrating high-level skills in these fields in SSTC, and these tasks could be extremely versatile and useful for a different series of cases. Also in this case, we have a test study, always related to Jupiter, but a different case. We started from the work by Sindoni et al. That characterized white ovals that are cyclones on southern hemisphere of Jupiter. We applied computer vision techniques to these images, to this data, and we extracted for a single image, in this case for a single area, but we are extending the number of areas under testing. We extracted information about the structure of the white ovals of the cyclones. Of course, our final goal is to make this approach automatic and so usable in a very final stage, usable in our tools. This is a very brief explanation of the work. We start from RGB images. In particular, these are images made by using different radiances, different wavelengths that best shows some particularities of the Jupiter atmosphere. In particular, the top image is the number densities. So the red channel is NH3 number densities. Green is NH4SH, and blue is N2H4. The middle image is the same but with elevations, and the bottom image is made with volume mixing ratio and relative humidity of NH3 and the temperature. The so-called surface temperature of Jupiter is the temperature of the cloud, of the first cloud layer. We apply this software of computer vision that uses color constancy and an image automatic mapper of the RGB and found some particular features of these images. For example, color, shape, orientation, size, and so on. Working on the combination of some of these features and combining them inside the single image and across the three images we used here, we detected the three cyclones in the image, and tentatively also we found that one is cyclone and the other two is anticyclone, as expected by the work by Sindoni, that used a much more computer time-consuming software. More details about these works. This work will be at the EPC DPS meeting on September. This approach could be extremely useful because it's completely horizontal and therefore applicable to a wide number of cases, different one from another. It only requires images and prior knowledge, because the researcher has to insert knowledge input to manage the data. For example, it can be used for planetary atmospheres, surface features, for example, rock detection or crater detection. Also for celestial transient, because if you're looking at the sky and you see something that changes, you could use it. for Earth observation, and so on. This is what regards HPC and artificial intelligence, but I also prepared another slide, an additional slide, talking about our tool about exoplanets. The name is Exoplanet, wrote that stands for Exoplanetary Analysis 3D Tool, and has the characteristic of finding not only planets, exoplanets, but systems. So you can search for a planet with a predetermined characteristic, and after searching on different databases, we are planning also, we hope to use also the merged catalog of Eleonora Alley. After this search, it grouped the planets in systems. So you shift from the exoplanet searches to exosystem characterization. You can also see the 3D visualization of the system, and you can, in this way, try to find similarities between systems. Okay, this is the conclusions. A powerful HPC machine is going to be acquired at the SSDC, and we are already planning cases, scientific cases, to exploit its characteristics. Some computer vision techniques are under development and testing. They are already developed, but we are testing them to make them more robust. And of course, merging these possibilities to the new version of Matisse will constitute a crucial milestone for all the activities of solar system exploration at SSTC. Thank you, and I don't know if there are any questions.
Thank you very much, Angelo. There is some questions, consideration. Just a curiosity, why Dell for the infrastructure? Why the choice Dell?
Why?
Why you chose Dell? Dell.
Okay, it's not my choice, but it's I think a Nazi and a Nazi choice.
Okay, thank you. Now we go to the second speech. I would like to invite Giuliano Taffoni and Ugo Becciani. Giuliano Taffoni is not present, so the speech is by Ugo Becciani. Thank you. And Ugo asked about LOFRET, the computing infrastructure.
Non c'è.
Ma sì, c'è. C'è da stare. La 14, l'ho messa.
Lascia perdere le bellezze dell'INAF.
Ecco. Grazie.
Sorry, Giuliano unfortunately had personal reasons, and yesterday he said me that I was just taking the flight. Say, Ugo, can you give the talk for me tomorrow? Oh, I am happy. Okay, sorry. So I'm here for Giuliano. This is non-English, but Latin, dulcis in fundo, allows to me to say this. Okay, start with the presentation of the computational infrastructure we are building for LOFAR.it. LOFAR.it is the Italian consortium that is made by the INAF and the University of Turin for the participation to the LOFAR International Telescope. The ILT is an interferometric array of dipole antenna distributed in 9 countries: the Netherlands, Germany, France, Italy, Poland, UK, Sweden, Ireland, and Latvia. It is mainly based on the activity of 7 LOFAR key science projects that drive the science that is given by the instruments. The 7 key science projects are respectively cosmic magnetics, survey, solar system, cosmic ray, transient, pulsar, and DOR. The LOFAR telescope have 53 stations. 24 are based in Exclu, and 16 in Netherlands, and 13 in Europe. The LOFAR station consists of 96 LBA's antenna, low-band antennas, that operate in the range from 10 up to 90 megahertz, and 48 HB antennas, high-band antenna, that operates in the range 110 to 150 megahertz. In Europe, the antennas are based at 6 in Germany, 3 in Poland, 1 in France, 1 in Ireland and UK, and 1 in the next few months in Italy. The LOFAR instruments is an instrument that will produce imaging with a resolution of few arc seconds. Potentially should be also lower than arc seconds, but this means that there is really a new scientific insight in low frequency and in the radio astronomy. And for this reason, potentially the LOFAR will attract a large community that could be interested in this kind of data. The key project will drive the scientific development of the LOFAR instruments, and in fact LOFAR, we can say that is made in terms of co-design, in terms that the needs of the scientists determine the design of the LOFAR instruments, also for data analysis and data acquisitions. It is the biggest SCA pathfinder in the low frequency. And for this reason, our researcher that becomes aware and capable to manage data from LOFAR will be a little bit more prepared for the management of the data that will come from SKA. So it's a big opportunity also for our research to be able to manage this kind of data and to reduce this kind of data. About the Italian consortium, for the next few years, we have some specific targets. The first is to build the LOFAR 2.0 station that will be in Medicina, for instance, for 2021-2022. We have already built the first version of the data analysis infrastructures, the computational Italian infrastructure for the Italian consortium of LOFAR. And we are starting to implement a technical and a scientific collaboration with Astron for the new version of pipelines, both in terms of data analysis and in terms of pipelines of the radio telescope. This means that we want to address the community to be able to work with LOFAR instruments in terms of science, but also in terms of technology, to create the competence in both the directions. And we are fostering the participation of the our researcher in the key projects that play the main roles inside the instruments. By the way, even if researchers are not inside key project, we have some guaranteed time, observing time, for project that requires a specific target, even if they are not inside the key projects. The LOFAR IT consortium is managed by the board. The board is coordinated by Gianfranco Brunetti from Istituto of Radioastronomia in Bologna, with myself, Federica Govoni, Francesco Massaro, that represents the University of Turin in the consortium, Jader Monari and Roberto Scaramella. There are 3 working groups, 3 boards. The first one is the Science Advisory Committee, that is led by Andrea Ferrara, that evaluates the proposal and the request of participation of our research in the key science groups, key science projects. Then there is a technological joint working group between Astrond and INAF, because when we entered in the LOFAR, International LOFAR Telescope, we create also projects to be part of the LOFAR 2.0 version, with the joint development for the receive control unit, and eventually some modification that will be necessary for the LBA's antennas in the instrument. The third group is for the computational infrastructure, that is led by Giuliano Taffoni, that I will present in the next slide. The roadmap and the status. We can consider March 2018 the first official point when INAF officially accepted and approved the LOFAR IT consortium. On April 2018, the ILT board approved that our consortium be part on the international LOFAR consortium. Then we have 2 calls in August and November of the last years for proposal and for the participation in the key projects. And in last October, we have the deployment of the first release of the computational infrastructure. And last week, we had the first Italian school for LOFAR, for data analysis and pipeline data reduction, operating in our infrastructure. The impact on the Italian community is rapidly increasing for the instruments. We can say that after the approval of the LOFAR Italian consortium inside the ILT, there are 17 full members in the Sarviki projects and 1 executive body member. So we are, Italy is the third, Italy consortium is the third contributing country in this key project. We have also representative members in magnetism, we have 5 members, in transient, 3 members in solar key project with 2 members. There is also an increasing number of requests of hours of observation. There was about 90 hours requested per cycle. And a cycle lasts 6 months. So we have already 2 cycles. We consider also the cycle before the constitution of the LOFAR IT consortium, because this was already one thing that was in progress, more or less. And about the production of article and science, in 2018 we had 17 papers produced by LOFAR, and 2 of this paper was led by the Italian principal investigators. And in 2019 we expect to have about 25 papers. 4 or 6 of these will be from the Italian principal investigators. The LOFAR computing model, the general LOFAR computing model data flow, is represented in this slide. The stations ingest data more or less at the data rate of 240 gigabit per second to the first system, the real-time system, that is the correlator. that is linked with the several channels in UDP way with the stations. Then the correlator after the correlation produce data that are given to the second step for the offline processing at the data rate of 110 gigabit per second. And after the execution of the pipeline in the offline processing system, data are ingested directly in the science-ready status in the long-term archive at the data rate of 2 gigabit per second. About the correlator in the central processing system in Groningen, we can see how this system is corresponding to the co-design. In fact, at the beginning, the system was a typical HPC system based on BlueGMP machine, a typical HPC system. Cobalt was the name, that means a correlator and beamformer application for the LOFAR telescope. But after a restyling, a new versioning of the pipeline that are used for the correlations, the F stage and the X stage, both for Fourier transform and cross correlation, now are implemented with GPUs. And so the new version that will be prepared for the correlator is based on nodes of Dell with dual Intel Xeon, but with each node provided with 2 NVIDIA Tesla Kappa 10 for the GPUs. The second step of the LOFAR computing model is the central processing CAP4 in particular. Each observation produced more or less after the correlation 30 terabyte, more or less depending on the time of observation, the frequency and so on, many other parameters, but in the average is 30 terabyte. That are given to SPE4 that run a specific pipeline depending on the specific type of observation. This means that after the correlation, using 50 computing nodes with 12 cores and 256 gigabytes per memory for nodes and a parallel file system, we have about 16 terabytes that ingest direct the long-term archive. Or both of this option, these data that are ready for science, not totally resolved for science, are given also to local facilities that are the national facilities, like our facilities, the Italian facility. When the researcher normally run the prefactor that is used for calibration, that ingests these 16 terabytes and produce 500 gigabytes. Then the initial subtraction that is is for sky model subtraction from the visibility, and then the processing name, the pipeline named factor that produce the final high resolution wide field images with the production of about 300 gigabytes and 3 terabytes of intermediate data, more or less. One of the challenges of all this process is the ingestion of the long-term archive, because up to now we have about 20 petabyte in the long-term archive. Much of these, we can look at the graph on the left, on the right, okay, my right. These data are stored in the Sara Computing Center in Netherlands, but part of these are also stored in Jülich, and now since 2014, some data are also stored in Poznan. About this data, we can look at the second graph that is named the staged data. In the gray zone means that these data are not public, are reserved to the key science projects. So it is important that these data have specific demand for the long-term archive. And another graph that we can see is the frequency, the file size distribution that are ingested in the long-term archive. If we look at the peak, more or less in the zone of the peak, this data ranges from 10 gigabyte up to 1 terabyte of data, the dimension of each file. The ingestion currently have they grow like 6 petabytes per year. And we have 1 billion, more than 1 billion of files that are given produced. LOFAR IT Data Working Group has provided design of the hardware and the software of the Italian infrastructure for data reduction in the LOFAR nodes of the infrastructure. The group provided for installation, configuration, management, and give technical support to users that want to reduce data using the pipeline that I mentioned before, Prefactor, Factor, and other pipelines, giving the opportunity also for testing and development for new pipelines. In fact, we have already contact with the person that developed the pipeline to optimize the pipeline and to increase the performance of the pipeline itself. The new organization of the group is given in 3 tasks. There is the task 1 that is for user support and training, that will provide document manuals for the user of the infrastructure, and the guideline for best practice, and will offer help desk and support. The task 2 that is for infrastructure, for the management of infrastructure, the software development, deployment of the pipelines in the infrastructure, and the task 3 is for the collaboration for the optimization of the pipelines, also with Astrone, with some key science projects. The infrastructure is distributed in Italy. The first node is in Turin, where we have a free fat node on Occam, the big supercomputing University of Turin, that will be used mainly for the prefactor phase and the initial subtraction. The second level is a distributed infrastructure in Trieste, Bologna, and Catania. Each nodes have 4-6 nodes with the memory ranging from 256 gigabytes of RAM up to 512 gigabytes of RAM. But it's important with the storage that range from 40 terabytes up to 60 terabytes and the parallel file system. Sorry? Okay. It is important also to note that was made a choice for simplified access to the resource and the uniform users. For this reason, there is a group, Francesco, that is here, who is one of the persons that prepared the containers that are deployed in the infrastructure. And they, in some sites like in Trieste, the containers are used also with the scheduler PBS in a bigger infrastructure. We have a parallel file system in the node of Trieste, Catania, and I don't know if Francesca have already implemented this also for Bologna sites. By the way, the parallel file system is one of the targets that our infrastructure will reach or we will use. For the containerization, we chose the singularity because we want to be platform independent. We want to have the minimal overhead and to offer the maximum simplicity in access to the resource. But the choice for singularity probably was also taking about some consideration on HPC platform, because singularity is more adequate than Docker in distributed environment, shared environment for HPC. We also have implemented a container repository where the versioning of different containers that Francesco, with the collaboration of the other person of the working groups, is operating in order to have a history of the deployment that we do. Prefactor, as I said, lasts more or less 1 week of run. Factor needs more or less 1 month of run. We also are working in DDF, that is an alternative pipeline that is made for the Sarvekisans projects. And we already started the collaboration also for this kind of pipelines. There were some tests that we do in Trieste and Catania, that we, considering the scaling of the number of cores in the infrastructure from few cores up to 40 cores, and the conclusion was that the pipeline has mainly I/O time dependent. So it is important to install parallel file system, and we need at least 10 cores and 256 gigabytes of RAM in each node. The last slide.
Okay.
We are looking also towards the futures for the exascale. We decide to provide the use case of LOFAR pipelines for the project EuroExa that is founded by Europe in the H2020 program for the next generation of high-performance computing, that is the exascale. And with this experiment that is highly I/O demanding, we give our contribution for the big data application towards the exascale, also looking for the new generation of data that will be SKA. And I want also to thank all peoples that made the working groups and that are here listed. There is a lot of person. This means that is an interesting aspect for our community.
Thank you, Ugo, for closing this marathon. Okay, question? Sound of silence. Okay, the program, oh, sorry.
Yeah, I have just a comment about probably a remark that is useful to stress in order to, enhance the synergies between particle physics and electromagnetic follow-up.
Yes.
For example, LOFAR has unique example of having also solid-state particle detectors mounted on the stations. So in the particular transfer buffer mode, you need to store the raw voltages of the stations for a few seconds because it's too much amount of data, but it's enough to reconstruct the particle, the electromagnetic shower from the decaying spallation of cosmic rays, very high energy cosmic rays. So it's a working case of multi-messenger astronomy routinely implemented in a facility which serves both as a radio telescope but also as solid-state particle detector. So we can probe energies we are at present billions of times more than what we can reach at present with the ALHC in run 2. So 10 to the 17, 18 electron volt, which is amazing to study particle acceleration in our galaxy.
Okay.
Thank you.
Thank you.
Other question? Comments? Yeah. Okay. The program, thank you again, Ugo. Now we start for a discussion, but of course the program is at the end. We are appreciate if Christina give me help in this landing approach to our journey. So I leave my word to Christina.
Okay. Thank you very much. So thanks for to the speakers of this session, of course. So with this last presentation, have the perception of that the user has to change their approach to the scientific data, because of course they cannot more download data and process by themselves with their laptop. And that is, I think, well described by Ugo. This is a pilot project, but of course will work for LOFAR, for the Italian contribution to LOFAR. And this means a change in mind of our users. So we have to convince them, and this also will be reported in the wrap-up session. We have to... What are you doing?
Nothing.
Okay.
No, nothing. I just
Nothing.
change
Okay.
the background, but I do nothing.
Okay. So now what I was trying to say is that probably we have to convince the average astronomer to change this approach, offering something that has so much added value that he cannot operate without. He cannot do their science without this important service, the plethora of services, support by specialists, by hardware, by infrastructure, by resources in general. So I don't know if this will be feasible easily. Of course, we have to train the community. And to do this, we already started in the past. For example, starting the vivo school. Riccardo and Marco are the main actor of that. Was the main actor? Well, sorry, the main actor of that. And the goal was reached because the virtual observatory was known. So we have to again do the same path and try to organize seminars or web seminars because it's much more easier and less expensive in order to train our users. I would like to ask a contribution, of course, from our chair about this. What about Gaia? Do you had some training for the users, or do you have to give support for investigating the archive? Plus, no? Do you? No users at all? So, Mario, could you comment on that? Really?
Remember, ours is an operational.
Okay.
So we're just part of the ground science data analysis, okay, which was not taken up by ESA. Gaia is an ESA mission. So for now, we have only through data requests. Okay. We only have, so to speak, internal users. I don't mean the scientific support, which is SSDC. They're doing a fantastic job on that. So no problem for the released data. Mm-hmm. Okay. So what we have shown, that's why I call it TLS. There's nothing to do with it. Mm-hmm. We have many users. But these are the internal pipelines. So for us, is like no users. Please stay away. Yeah.
No, in the sense that we have a lot of astronomers in Gaia, in DPAC, okay, that can use the data of Gaia, okay, but out in DPAC, yes, outside the Data Process Analysis Consortium, because until the last release, the intermediate data, all the data in the database are not published. So we needed to think about after, okay.
So I would ask the Vincenzo, that was part of the ARC. So if you can comment your experience. We got also Sandra Burkutean that has the same experience, I suppose. You are okay.
Much more than me, for sure, because at the moment, yeah, at that time, yeah, my experience at the ARC at the beginning of my PhD. So I spent 3 years there experiencing the activities, the routine activity of supporting users interested in submillimetric radio astronomy. So from the very beginning of the proposal submission, so to help people and to grow the community in order to be aware of the possibilities offered by these new generation instruments like ALMA, which impressive sensitivities reached in few minutes, and then proposal submission, organizing workshop events in order to then follow up when fortunately the proposal is approved, to have observation, to have a contact feature within the regional center, for example. About that, Sandra, for sure, will have much more experience for quality assessment, to follow up and to reduce the data, and then to provide PI all the information and also support for further process the data up to science-ready data products with using the cluster provided at ERA, the R cluster devoted to data calibration and post-processing. So I think that then
she could also answer some question about the cost of this operation. For example, when there is the new cycle release of the OT, I know that there are several meetings in which there is an exploitation of the new feature offered by the ALMA. So can you comment also on that?
Yes, I think the lessons we learned from the ALMA Regional Centre, first of all, is that it's really important to have a network point where the instrument users can go and ask questions, and also where you've got the expertise localized on how the pipelines work, people who really know in depth, you know, what happens at each data reduction stage, because it's all about automizing everything and putting it into long pipelines, but you also need to have the expertise localized to actually know how the steps work, and if something needs to be changed, or if there's PI who has a special request, that there's the flexibility to go back to the data reduction process. Another thing is that a regional centre also offers the ability to train the community, and that ties in with your question about the observing tool, which is used to prepare ALMA proposals. So, for instance, this year we're going to have, for instance, a workshop on big data in relation to SK, specifically for PhD students, postdocs, etc., just to get to get the expertise flowing in, also for younger students and master students. So, yeah, that's pretty much it.
The question also was about how is the ratio between benefits and investments from this? Because you invest a lot of resources.
We do invest a lot of resources, but we also get the feedback from the community who are happy. Again, that's another thing. If you've got a regional centre, then you get feedback from the users, which also means that you can improve your pipelines, you can improve your instrument, and you can maybe have a vision of what you want to develop in the future, because you just get the immediate feedback from everybody.
Thank you. Thank you very much. I would like also to highlight that the infrastructure is, as mentioned by Magda Arnaboldi, the archive is an instrument. Okay?
Yeah, because that's, I was joking before, but serious on the user side. But now let's concentrate on the archive. Now Gaia is really an example here, first example of, now, hadn't been an extension of 1.5 years, we would phase the future of this archive that we have at DPCT today, because the nominal mission would end in a month. So you see, we really have to think about if it's worth and what is worth keeping, curing and preserving. Now, I don't want to go into details here, but you understand that the data get corrupted. Many data in the database are in the form of blobs, which is very convenient for this Java stuff. Sorry, anytime I think of Java and GBeans, I get the creeps. But anyway, so these data are not, okay for the database. Database, it tells you that it's not corrupted, but it's not readable unless you have the data model, the correct one, with this comes to the GBeans. It's a nightmare. So we really have an obligation here. Now, we can decide that this is it, and we have to face this issue. When a program is finished, it's finished. You close it up, you can do del aster, and that's it. Okay? Or, as I say, you measure the value, and you decide if this is a gold mine or not, or a silver mine, or a copper mine, whatever that is, okay? And we would face this today, okay? And this is nothing to do with users, but the value of the data, the investment in the data, how much, are we getting back? Getting back the investment is not just how many users you have, what you can do with it, as I said. there are precious data which have not even been touched by us. I mean, all the electronics, all the temperatures on board of the satellites, the way the temperature distribute, these are precious data for our engineers. And I'm not saying anything new. I mean, people understand this, but maybe this is new for this audience, or they heard something like that. So, and this is an issue here. So I'm looking at, and we might, as I said, we might even sell, quote unquote, these things. That's something I expect my institute to address, and I think should be part of the consideration of the facilities. Now, I heard of this huge thing in Bologna. I mean, this is perfect. It is the time to say, yes, we are part of the stakeholders. What are we waiting for? What is our director of science?
Okay.
Yes, I try to
convince
him, but
people are very pushy, so let's go up.
Yeah, I would also suggest to move upstairs. It's a better option.
Ample space in that room.
Yeah, can I add something? So we can
Of course.
Write an email to people access maybe. Because one of the points is we are discussing, for example, from radio side about interferometry, and we already have, for example, in Bologna, the ALMA Regional Center serving for one interferometer, which is ALMA operating sub-millimeter and also. But we also have low-frequency interferometric facilities with some other problems connected to the atmospheric calibration effects. But basically, there is already the expertise also in the ALMA Regional Center, the Institute of Radio Astronomy in Bologna, to face and to provide support to the community. So there is the concept that could be stressed, is what is called the Interferometric Center of Expertise. So empower, basically, what already exists in our institution in order to serve different instruments connected with different problems about data calibration. So we have problems connected to low frequency, but we already have main power and something that should be in the vision developed and supported. But so far, there was the ALMA Regional Center as a sort of a limited scope, only devoted to ALMA staff. So I think that there's room for empowering and expanding the already existing expertise within the institute. So that should be taken into account in the high long-term vision. Okay.
Thank you very much. So you are pushing for collaboration with also.
I know that at the political level we have the government that changed the situation in our institutes very rapidly. And it's what limits naturally the time amount of the scope of, but we should also have during the fixed term positions of the CDA committee, steering committee, and every kind of governance team, that this limited amount of time should be spent in order to set the stage for something more. Yeah.
Okay, I would. Yes, of course.
Next time you're not going to invite me.
No, I will invite you because you contribute and you stimulated discussion.
He's really making an extremely good point. So I have to mention another thing. So you think that astrometry is the easiest thing there is, okay? And I think my colleagues here from SSTC and a few others can understand. Now, the Gaia data, the astrometry, the absolute stuff, has been done using relativistic models. This is the very first time. There are only two nations that have produced original models. One is the Russians plus some French, and then Italy. It's not just the photons, but the same representation in general relativity of the observer, the satellite. This is a unique thing. For the first time, I think we have something, models, which is the equivalent of evolutionary models, or as he says, the fringe model, visibility models. I mean, this is precious. Now, I am not going to release a bit of that software, because that's our expertise. So if I give you the raw data, just go ahead, do the astrometry that you know, and then you'll miss all the parallaxes. Okay? So that's the point. Okay, so I don't care if you want to give up the data, but I mean, what do we do with the software? And we're talking about almost including the focal plane reductions, including the metrology reduction. We're talking about almost 200,000 lines of code. Okay, and I'm not talking comments, almost the real thing. So this is the effort over 10 years. And so how do we deal with this? This is precious stuff. So this is just the astrometry. Yeah?
So I have also other two interesting things to ask. That is one for you, Pia. There was you in your presentation suggested that investing a lot of resources in developing tool in order to make the data accessible and understandable by several communities has a big return in terms of usage, in terms of visibility of your facility, etc. Probably also training the community is something that you can evaluate, but of course, if you could comment on that.
Yes, no, we are convinced that this is something which clearly is an important investment in terms of money, but also time of people. So we need people dedicated to this. And training is very important. And for this reason, if you go to our websites, the one which I have indicated, you will see that there have already been two schools done just for training people, having those pages downloaded or accessible, just to show them what they can do, with some explanations on data analysis. So what are our data? So some theory, something on the analysis, what you can do with very simple codes. And we will organize more, because people can also contact guys. So there are emails, and then you can ask. We want to organize something. I don't know, in this place. Are you available, or something like this? We are convinced that it is important. Also having in mind, as I told before, students. So also young people in the community, or students in physics at first years, and because even if referring to students, they are not going to do this science, it's good if they can train a bit, thinking and understanding better what we do. So even if one of these guys was attended our courses, or during his studies has, tried some to see our data are and so on, will be a doctor in the future, or do something else, we think it's important, because he will more able to understand the results and probably to support our science. So this is, I think, something. And I also think that once we have done the effort to organize things, then it will be much easier. So once the basic tools have been organized, and we know that in the end, when we write a code, this code one day will be accessible to others. So we can start from the beginning, in writing, more comments, or in using something which will then lead to the possible opening the data to the community. So I think it is hard now, but then at some point it will be easier. Yeah.
And also, young people are very good debugger of our results. I would like to ask Francesco if it's possible to comment the results for the Loafer School.
Well, it was well accepted. There were like 30 participants. And it showed a great interest also outside of the typical radio astronomy community about the topic. And it served us to try to test our infrastructure. Also to debug. Really is a good test bed for an infrastructure to prepare to receive loads from outside, also. well, is a controlled environment. So you have like a data set that is not like is controlled, but served us to discover a few bugs. So it was good.
Good in both directions, from the perspective of the attendant and also from the teacher side. Okay, if you are comfortable, I could make the wrap up, or if there are other things to discuss. I think that we all are really tired.
I think there's a lot to discuss, but I think there are a lot of people at the end of the game.
Okay, so... Sì. Mauro, may I enter my credentials?
Yes, check anything from Mauro.
Oh, another. Non ricordo. Me lo ricordo. Ok. Perché no? Okay, let's see in this way. I don't want to spend more time on that. Well, the workshop, in my opinion, it was really successful. We had a lot of people that participate. I would like to thank you all, in particular the speakers, of course, because they contribute directly to the discussion, giving us a lot of hints, presenting situations and also problems, and also, of course, new cases. I would also like to thank all the people that contribute to the discussion, because that was the main goal, to have a discussion, to create a community of technologists and the scientists that collaborate in order to improve and grow the community at large, the Italian community, in order to have something that is ready for the big facilities and for the future in any sense. So we extrapolate some lessons from this workshop. I summarize in few points. Probably I miss a lot of things, but sorry for that. I'm a little bit tired too. So it is only a summary, not exhaustive, of course. But we had some session. The first session was dedicated to the status and what we did, what we already have. The other session was much more contributed with external inputs, and of course to new project, to new issue, to ideas, etc. And then we got this last section that was dedicated to the technicalities, basically. So I would like to highlight that the data coming from several providers around the world, and released by several site institutions. I was mentioning Italian data, and because the UTG is spread over all the wavelengths, and so we had a lot of different approaches, formats, the standards, and whatever, and in particular different necessities for different communities. So we had some introduction to what is the current situation that represents, of course, this is only an order of presentation, not something different. We got one INF infrastructure that handle, of course, some kind of data, simulations, radio data, or optical, ground-based. Then we got, of course, the ASI data center that currently is dedicated to space mission and probably also store pathfinders for the archive of CTA or something like that, or ASTRI.
Just to mention that it's not only ASI in the sense that there are about 15 enough people who are working at the SSDC, so it's...
Okay, it's a joint venture, okay, of course. And
it has been correctly pointed out by Filippo this morning that specialized data center.
Yes, thank you. Thank you. So, and we got also several project-oriented infrastructure. I don't want to mention all because, of course, we got a lot of contribution. So please don't take bad this, but so that we got, as I already said, a lot of hints. We have seen strong tools for data handling, visualization, and analysis. That's the goal of Science Gateway, of course, but sometimes they are used separately. So we got data in one side, and we got visualization in others, etc. Then we got a really important information from outside Italy. That is that we got from the invited speakers. We have two approaches. The first approach was much more oriented to the user, and the other was mandatory driven by some in-house defined standards. I was mentioning the first that is much more related to the VO standards, that is the CADC, and the other is ISO, that is a de facto standard because they have the power to impose this, at least for the telescope, and of course they are very important. So, but I would like to stress that in any case they use standards, well-defined standards. So no collections that are not, well, everyone do whatever they want, but they plan the way in which approach data and the data analysis and whatever. So they got a vision on that. Then we understand that pipelines are not always available, and moreover, they are not shared, also if they could be available. We got various levels of high-level science products, so complications, okay? And then we got the contribution of Filippo, our scientific director. What we need is mentality, effort, and infrastructure. The first is really mentality. We have to try to exit our boundaries and collaborate with the others in order to improve the user experience. Of course, efforts and infrastructure, well, we know that now we cannot limit to one PC or one small cluster, we need something more. And, okay, also he mentioned that we need new figures, so data scientists as well as support astronomers, not for the operation, but for the data. Then we got a lot of hints on open data and open access. So interoperability, data curation and preservation. That's data curation and preservation also of software, documentation, and publication. This is really important because it gives us the possibility to have more citations, to allow the people to reproduce our results, and this gives, of course, an added value to the science that we produce, because it is trustable. We also had the perception that no common rules among various experiments and archives. What Riccardo said in Italian is, and I can repeat in Italian, se abbiamo un grosso progetto, allora ok, rispettiamo diciamo la direzione e gli ordini, altrimenti evviva, ognuno fa quel che vuole. This is not a good choice, this one, of course, because increase the chaos that we must handle, at least. And then we had the perception that it's not important to store everything locally. We can also link only metadata. Severin suggests about this, but in that way we are completely interoperable. Then we know that, as mentioned, in the sense that we also understand that we lack of computer scientists, so we got difficult of finding them. And we got difficult to guarantee permanent position, salary that are not attractive. And of course, we are not so competitive as other realities. Then, one thing that was several times mentioned is standards. We know the FAIR principle, we know the IVOA, several of us use the IVOA. We know that there is the RDA for interdisciplinary purposes, and one suggestion is to use a common data models, at least internally to one community. So I think that we can say that we got the Italian community, astronomical community. That is part of a biggest group, but of course, then we need, names was shown in my presentation, domain specialist. That means that the data scientist has to be not only a technical one, but also understand about astronomy and can interpret correctly the needs of the astronomical community. And we got as well the astronomy specialist. This is something different because the first interact with the data provider is in the middle between the data provider and the users. And the second is someone that help the community to well interpret and understand the content of the data, and also to extract as more information as possible from the data. And then we got the challenging use cases, CTA, SKA, all of them are imply storing, to have a storage and also computation close to each other. So also in the case of having distributed infrastructure, etc., we would like to move the code to the data, not the vice versa, because of course. So now we had this. So criticalities. Okay, data curation and also reconstruction and reusability of ancillary, using ancillary data too. So for example, the telemetry. So we know that to reconstruct properly the scientific results, we need also ancillary information, not only the science exposure. We got private pipelines that limit a lot some usability of data. And then, of course, we have non-commonly adopted standard, and that's okay. And the last, we have limited interaction between working groups, unfortunately, because sometimes I know that one guy is expert of that, but I'm lucky because I know. In INAF, we got a lot of expertise. We demonstrate in this workshop that we got, and also, of course, in Italy at large. But there's sometimes we reinvent the wheel. So, or we must invest a lot of effort in doing something that another guys could do very fast. So finally, I would like to put some ideas. Let's call it ideas. This is the roadmap. What means? This means that if we want to improve the scientific usability of our data and make a cluster in which we collaborate, we should convene around a table, as written, with endorsement of INAF Directorate, of course, because we are talking about INAF now. Find consensus, not impose something, but find the consensus, so agree on strong national interaction on overlapping activities. Why don't we have to coordinate ourselves? It is convenient for everyone. Then we got the definition on common strategies and strong cooperation and coordination. And highlight individual local contribution within a national landscape. So what me pushed last days when I was asking about who is the person that could be the reference person for that. Well, it's not just one person, of course. Then we should use internationally agreed upon standards, proposing and improving new standards when needed, because of course the current standards are not complete of all the use cases. Then we have to follow the data publication. This will increase the scientific return and ensure growth of an Italian community. So data publication is not only related to the scientific data, so the data set publication. This means that we have to follow all the chain that start from the proposal and end to the papers, DOI included, of course. And then we have with the last discussion that we had to change the user approach, not to force, but to convince them that to convince the community that now we need both computation and storage outside our office. Okay. I don't know if everyone is agree or would like to comment. There's no a chair about this. Where is the microphone? Have you got questions? Do you want to comment? Riccardo, please comment on this.
Just no suggestion is okay. No, the roadmap is okay. I fully agree with that. There is a lot of point of the discussion, a lot of point of interest about that. The ICT is try to working about that from the last 5 years. I think there is a lot of work that we have. Yeah. Okay, and there is a lot of work that we are going to do. And the strong national interaction, the strong activity that we have with our scientific director is with the futures, because to many points that we are already discussing these days. The really important point that these 3 strong, heavy, cloudy days not be the only one. So we need to create a following about the activities. The many followings, not just we have to start to do anything tomorrow, but a few activities that remember what we define these days, what we have to already plan, a roadmap and so on, but a lot step. I remember to the peoples that in-house and not only now, but with friends, with college, in other institute and so on, we have all the Lego bricks. Please play together. And remember that the lunch is not free. Now come here. This is the name.
Just one comment about the roadmap. This is good, but I want to tell that, for example, what was happening in these years for the computing. There was a change. Where is Riccardo?
Riccardo's here.
No, I have to look your right. There was a change in the management of the infrastructure. We go from some nodes that offer computing facility to a national and distributed with the management at a national level of the computing. Chip is an example of this, but also LOFAR is an example of this. So I think that the same rod should be given also for the management of the archive and the infrastructure, because we have to move from local expertise that is important to a national and not only distributed but managed distributed in terms of management at the national level. This not means that the archives should be necessarily distributed in different sites, but the management should be, in my point of view, considered like a national resource. This is.
Like E2 already is.
Yeah.
Gaia and so on, because the main point of Filippo was, please take aside what he has from E2. E2 is enough infrastructure, like chip. Chip is the infrastructure, like any things. We are want to work about enough infrastructure. One, we have to talk. I like today the talk of Fabio. Unfortunately, it's not here, moving. But when we're talking about an international collaboration, we have to route enough / Canadian, Russia, whatever you want, but enough. Because it must be think about the infrastructure. And you think about the infrastructure, you can go to this roadmap, and this roadmap is successful. If you're moving again, like in not observatory, but like a Riccardo infrastructure.
But it's the same also for development of pipelines. So we are not coordinated at all. So also that is something that could give us the chance to be better, to do better, sorry. Of course, as Riccardo said, year 2 has already not, well, of course, there is a tradition in Trieste because we handle several telescopes from there, but you know, the radio archive is in Bologna and will be also in SRT.
Yes.
So,
but it was not totally managed, in my opinion, at the national level. For example, in ICT group, we don't discuss about the policy of the archive.
No, but we can do. We make and so on. But it was one of the points that we are going to discuss. But now we are talking not about the city group, that is, of course, we will discuss it, but we have to talk about the users. Please, this is a roadmap about the data, but please make a suggestion. Try to make a suggestion again, not just send an email. It's possible to do it, okay, don't answer next time. We have to do more and more, because, of course, we are not 200 people, we are just a few people, but we can do a lot of work together. For me, it's okay.
Other ideas? Other comments? Are you agree? Do you want to collaborate? I propose to have another meeting, probably not this year, of course, because it's too much. There are several ones, okay. But next year, I would. We had also this year, yes, of course. Yes, but this meeting takes us 3 days. I don't know if in the ICT meeting we can take 3 days to discuss
in the ICT
about
meeting
this.
we will report this one. In the ICT meeting we report about the software. In the ICT meeting we have report a lot of evolving position that we have in these last years. That we have a growing up of evolving situation and so on. We remember everywhere that we can do a lot of. There is a lot to do, but we have a chance also to do a lot.
Okay.
Thank you very much.
Thank you very much. Really, thank you.